Building functions part 2. We've already talked about our parent functions, and we're still going to continue working with these, and you need to make sure that you know what your parent functions are. So linear, y equals x, is your straight line that goes through the origin. Quadratic is your parabola. It can look like a smiley face or a frowny face. That's y equals x squared. Your square root graph, it starts at the origin. Your inverse graph, 1 over y equals 1 over x, and your exponential graph. So if we start here and we're just using the graph of g of x equals the square root graph, we're just going to start with the square root graph as an example. But remember, if it's plus k or plus any number, if it's on the outside, this is a vertical translation. And if you're adding or subtracting a number on the inside, so if it's inside the square root, inside the fraction, in parentheses, that's going to be a horizontal translation. All right, and we're going to talk about domain and range. So for the domain, you're going to look at your graph from left to right. How far left your graph goes, how far right your graph goes. So domain is left to right. Your range is from bottom to top. So bottom to top. So you're going to go how low to how high. It's always from bottom to top. Now, interval notation, you're going to use parentheses if a graph has an arrow or if it keeps going forever. And sometimes on some of the pictures of the graph, it may not have an arrow, but it looks like it's just going to run off the page. So keep that in mind when you're looking at your assignment. It's just going to run off the page. So it may not always show an arrow, but it's just going to run off the graph. So keep that in mind. Or it may have a hole on a graph, and we'll get to holes later. We're not going to get to holes today, but we will get to holes, okay? You'll use brackets when a graph has a definite starting or stopping point. So what we're going to do is we're going to look at drawing a graph and doing the domain of these functions. And for these, we're just going to focus on square root graphs just to kind of get the hang of doing domain and range. So first of all, what we're going to do here is we're just going to start with the parent graph, and then we're going to do the shift of the graph. So remember, the parent graph starts at, we're just going to do 3 points. So 0, 0, 1, 1, and 4, 2. So this is our parent graph. Now, remember that if this is on the outside, the plus 3 is on the outside, so that means it's going to go up 3. So every point that we have is going to go up 3. So we go up 3 here. This point is going to go up 3. And this point over here is going to go up 1, 2, 3. So here is our new graph. I took each point and I shifted it up 3. So if we first do the domain, we are going to start here. So we'll do domain. So this is the domain that I just did in yellow. So we're talking about x value. So domain is another thing. Remember, you talked about that in Math 1. So domain is how far left. The furthest left that our x goes, okay? So x, we're on this line here, okay? So we started at 0, okay? Well, how far to the right do our x values go? Well, it's going off the graph, okay? Because, we've got this arrow right here. So it's going to infinity. We express that using infinity, okay? So when it goes on forever, you use infinity. Okay, so now let's do range. We'll do that in a different color. So for range, we're doing our y's. So this is the lowest it goes. Okay, so the lowest y value. So now we're switching over to y's. So it's like, this is the lowest that it goes as far as up and down. So our lowest y value is 3, okay, because we're thinking in terms of y's. Now, It's going up. It's going up slowly, but it is going up. It's going, to the right forever, and it's going up forever. So it is going to infinity. So that is our range. So domain, you're thinking left to right. Range, you're thinking down to up. Okay, so let's look at B. So once again, I'm just going to put my 3 points for my graph here. So this is my parent function. This is where just the regular square root of x would be. Now, this minus 2 here is on the inside. So this means that every point is going to shift right 2 places. So if I start here, I would go right 1, 2. There, I would go right 1, 2. And then if I would go here, I would go right 1, 2. So here is my new graph. Okay, so if we do domain. Okay, so for domain, we're looking at x's. So here's my x. The furthest left it is 2. Okay, the furthest left it is 2 as far as x's go. And it is going to the right forever. It's going to the right forever. Now if I switch for y, so here it is y. So think how low it is in terms of y's. The lowest it is 0. That's the lowest it is. So think in terms of what is the lowest y value on the y-axis, go running up and down. It's 0, and it's going up forever. So we would say infinity. Okay, so moving on to C, if I do my points here for my parent function so I know how to move it. So this one is going to go down 1. That minus 1 is on the outside. Remember, outside shifts up and down. Negative is going to go down. So every point I'm going to go down 1. So here are my new points on my graph. So let's do domain first. The furthest left it is as far as x values is a 0. Okay, so I'm talking about x values. The furthest left is 0, and it is going to the right forever, so it's infinity. All right, now I'm switching to range. The lowest y value, so the lowest y value is a -1, but it's going up forever, so it's going up to infinity. Now for D, so here are my points, my original points. Now let's look and see what it's doing. It's got a +4 on the inside. So remember, inside shifts, it means it's a shift left or right. So a +4 means it's going left. So it's going left 4. So each point I'm going to go 1, 2, 3. Let's see, 1, 2, 3, 4. Means I'm going left 4. 1, 2, 3, 4. And 1, 2, 3, 4. So here's my new graph. Okay, so my domain, my x is at -4, but it's going to the right forever. And then for my range, my lowest is at 0, but it's going up forever. So my range, my lowest is at 0 because I'm going up or down, how far down it is, and how high it's going. Okay? All right, moving on. So given the parent function, we're going to write the new function as a result of the transformation. So now we are writing an equation. So shifted up and left 2. Okay, so up means it's going to be on the outside. Left means we're putting something on the inside. So left means we need to add some parentheses. So I'm going to do parentheses. Left 2 means I'm going to add 2. Don't forget the square. Up 3 means I'm going to add 3 on the outside. So that's what that equation will look like. All right, for B, I have g of x equals. So reflected across the x-axis, so remember that's going to be a negative out front. And I've got a square root of x. And then it just says shifted down 4 units. So remember, up and down, that's going to go on the outside. Down means it's going to be -4. So make sure I can clearly tell that's on the outside. So make sure that it's clearly separate from that square root so that there's no guessing for me if there's any writing. Of course, everything's going to be submitted through Canvas, so that shouldn't be a problem this year. Okay, so for C, shifted up 2 units and right 3 units. So right's going to be on the inside. That's going to be on the inside of this fraction. Okay, right 3, so that's going to be a -3 on the inside. And then up 2, that's outside of that fraction, so +2. All right, and then for D, we have f of x equals, so shifted right 5 units. So that's inside the exponent. So right 5 is going to be -5. We have inside that exponent, so -5 is in that exponent. Okay. Combining transformations. So this is like what we did just a second ago, except we've got more than one thing going on. And I've thrown some more in here just besides square roots. Now, I'm going to start off with a square root. So let's go ahead and put in the parent function. Now, we are going to, let's go ahead and write down what we're doing. So we're going to flip across x-axis. We are going to go right 1 unit, and we are going to go up 3 units. So that's everything that we're going to be doing here. Okay? All right, and then don't forget, one thing that you can also do here is you can double check your graph on Desmos. So I would recommend doing that just to verify that you've done everything correctly, okay? So let's see here. I'm going to go ahead and type mine in on Desmos on my computer here just to make sure that I'm doing mine right. Okay, so if I go ahead and flip mine, let's see here. Okay, so if I flip mine, okay, so if I flip those points, all right, then I'm going to go right 1 unit and up 3. So let's see here, right 1, up 3. Let's see. Okay. Let me zoom in real quick. Okay. So if we go right 1 and up 3, let's see, right 1, up 1, 2, 3, puts us there. And we go right 1, 1, 2, let's see, 1, 2, 3. And then right 1, up 1, 2, 3. There's our graph. Okay. All right, so now when we do our domain, our x value is at 1, and we are still going to the right forever. And our range, So our range is at 3 because we're looking at y values. How far, actually, sorry. Whoops, I messed up. I almost messed up there. Okay, so be careful with this one. Think how low this one's going. So this direction, think you're going, oops, forgot to switch here. This is actually going down forever. So you got to think it's going down forever. And you got to think it's going down first. The lowest, you got to list the lowest first. And this is easy to mess up because I almost just messed up. So you got to list the lowest first. So the lowest first is actually negative infinity. So you always list the lowest first. So list lowest to highest. And then the highest it is 3. So it's real easy to get that backwards because we're always used to thinking like left to right. So you list the lowest to highest. So the lowest is negative infinity. The highest is 3 because you kind of want to think you're going from down to up. Okay, so now on B, our parent function is a parabola. Now, I always do 3 points for a parabola. 0, 0, 1, 1, negative 1, 1. So our parabola, this is like our parent function. Now, what's going on in this graph is we would be going left 2, up 1. So every point would be going left 2, up 1. So left 2, up 1, left 2, up 1, left 2, up 1. So here is our new parabola. Now if we do domain, now think about how far left it's going. So this is actually moving kind of this direction. It's going to the left forever, and it's going to the right forever. So domain is left forever, right forever. So the way that we would express this is negative infinity, positive infinity. Okay? When we do our range, okay, the lowest that our point is right here. Yep, let me switch colors. The lowest our point is at positive 1, and it's going up forever. Okay? It's going up forever. Okay, so now when we get to C, remember X is just a straight line. Okay? X is just a straight line. You learned this in Math 1. Okay, and remember this is just your y-intercept, and this is just your slope, or m. So all that's changed on this one was your y-intercept, okay? So all that happened here is your y-intercept. Everything else stayed the same. So there's our new graph, okay? So for our domain, how far left your graph goes, well, it looks like it's going to the left forever, and it's going to the right forever. So it's negative infinity to infinity. And for our range, how far down is it going? Well, it's going down forever, and it's going up forever. So it's going from negative infinity to infinity. Okay, so last one, once again, this is a straight line. Okay, so here is our parent function. Okay, but remember, this is your y-intercept. So negative 1 has become our y-intercept. Negative 2 is your slope, which means it goes down 2 over 1. So if we go down 2, right 1, or you can go up 2, left 1, here is our new line. Okay? All right. So for your domain, how far left is it going? Well, it's going to the left forever, and it's going to the right forever, which is expressed by negative infinity to infinity. And as far as range, it's going down forever and up forever. Okay? Now, you always use parentheses with negative infinity and positive infinity. Okay, so always use parentheses with negative infinity and positive infinity. And you always use a bracket, and this was mentioned earlier in notes, you always use brackets with like a definite starting and a definite stopping point. Okay, but no matter what, you always use parentheses with infinity because infinity does not stop. Infinity keeps going forever. So always use parentheses with negative infinity and positive infinity. Okay, and then we can also go back and we can talk about using these as using some inequalities. Okay, so like for example, because you'll have some of these in your assignment as well. So like for this one, this could be expressed as, let's see, for this one, x is greater than or equal to 1. That could be expressed as an inequality. So to be greater than or equal to, if it's a bracket. If it's a parentheses, it's just greater than. Okay? If we go back to, so here, x is greater than or equal to 0. On D, x is greater than or equal to -4. On this one, x is greater than or equal to 2. On this one, x is greater than or equal to 0. So you could see some inequalities as well.